All right, so the first thing that we want to do when we're solving an equation such as this one that you see is to move everything to one side of the equal sign. So we're left with a 0 on one side. And I think in this case, it really doesn't matter which side that you move them to, but for this example, we're going to move all of the terms to the right side of the equal sign. So starting with this negative 10z cubed, we have to add 10, excuse me, make it a little bit more legible, 10z cubed. And what you do to one side, you have to do it to the other. And since z cubed is a different term, then I'll start a new column, plus z cubed. And then to remove this, or to move this 2z to the opposite side, since it's positive, I have to subtract 2z from this side, and it is a different term than these other two, so I'll start another column. And let's see here. Then these will cancel out. These two terms will cancel out, and the result that you have is 0. And bring down the equal sign. And so what we have here is z squared plus 10z cubed minus 2z. And so the next thing that we want to do is arrange these in descending order. So starting with the highest power, the term with the highest power, all the way down to the term with the lowest power. In this case, it would be 10z cubed, and the next one would be z squared, and then finally minus 2z to the first. And then next, what we would like to do is you notice that all three of these terms have a common factor in it. And the common factor is z to the first power. So we'll remove a z to the first, from each one of these terms. And inside of the parentheses, we'll have a, 10z squared plus z to the first minus 2. Okay. Oops. Get my colors together here. Okay, so notice if you know, when you remove a factor, if I was to distribute this back to each three terms, it will give me what I started with. So z times 10z squared will give me 10z cubed, z times z gives me z squared, and z times negative 2 gives me negative 2z. So now we have a situation where let's go ahead and factor this trinomial, because this can be split up into two separate factors. So next line, bring down my z, and so the results of this, and you know, at this point you should have you should have an understanding of how to factor trinomials using you can use the trial and error method or the AC method, but in the interest of time, the results of factoring 10z squared plus z minus 2 would be 5z minus 2, and that is multiplied by 2z plus 1. Okay, so these three this trinomial here, when we completely factor it, when we completely factor it, this is the result that I have. And if when you multiply all these together, there is a variable, there is a solution where if you plug in the correct solution in for z, it should result in 0. So here we have a situation where we're going to rely on the multiplication property of 0. So to quickly address that, if I had something, for example, let's say if I had 0 is equal to some factor A times another factor B times another factor C. I have three terms here. Three factors here, excuse me. So what that means is either one or more of these has to be equal to 0. All right. If A was a 0, then it doesn't matter what B or C is, it's going to result in 0. And then if A and B are 0, this would be equal to 0. If all three of them are 0, I would get the result would be 0. So that's the multiplication property of 0. So when I apply that to the setup that we have over here, then I can now find my solutions. So let's start with this factor here. I'll set z equal to 0, and there's nothing to reduce, so that lets me know that one of my solutions is z equal to 0. All right. All right, so let's try this with the second one here. If I set 5z minus 2 equal to 0, then I solve this thing for 0 to find out what z would be. So let's see. I will let's see, plus 2, add 2 to both sides, and the result is, see, 5z is equal to 2, and then now I have to divide both sides by 5. Oops, let me change my pen here. Divide both sides by 5, and what that does is that will eliminate this 5 here, and the result that I get is z all by itself equal to positive 2 over 5, and that is a second solution. Okay? Oops. And then finally, we take our third factor, which is what, 2z plus 1, and then we set it equal to 0, and we do the same thing. We just solve for z. So subtract 1 from both sides, and let's see, the result that I get will be 2z is equal to what, negative 1, and then divide both sides by 2, and so the result that I get, well, oops, these will cancel out, and finally the result that I get is, let's see, z is equal to negative 1/2. All right, and that gives us our third solution. Okay, and keep in mind that we started, this was a polynomial, to a third degree polynomial. What that means is you will have up to 3 zeros or 3 solutions for this particular equation here. So if I plug either one of these numbers in to the original equation, then I will get a true statement. All right, the left side would be equal to the right side.